Welcome to the Passive House podcast, brought to you by Passive House Accelerator, a catalyst for zero carbon building. For news, inspiration, and connections from all flavours of Passive House, check out passivehouseaccelerator.com. Sign up to receive regular updates about events, get your questions answered, and contribute to the community dialogue. There's loads of free information for experienced professionals and people just starting out on their Passive House journey. We hope to see you at one of our weekly Passive House Accelerator live webinars. In the meantime, here's this week's Passive House podcast.
Welcome back to a special component spotlight episode of the Passive House podcast. Matthew Cutler-Welsh coming to you from Tamaki Makaurau, Auckland in New Zealand. And I'm joined this week by Jay Fox. How are you doing, Jay?
I'm doing fantastic down here in Asheville, North Carolina.
Yeah, how's things there?
Still a little rough. We got running water back yesterday, so that was a big improvement. But still some communities out in the kind of hinterlands of Asheville that are struggling, but the supplies are pouring in, and we're optimistic about making a full recovery and rebuilding some of the neighborhoods that got a little destroyed by the floodwaters.
Yeah, that is a good reminder of the reality for a lot of people in that part of the world and further beyond that as well. I know it's pretty full on. You do actually mention that right at the end of this week's interview, but not in a huge amount of detail. But we are talking cladding and cladding systems, which are relevant to everyone in the building industry, but really interested in how this progresses from kind of the early stages of Aaron's story through to how they're doing some really cool stuff with some passive house buildings now. So we're going to be listening to your chat with Aaron Frazier from Longboard. And before we jump into this, we'll put some links in the show note, but basically, how would you describe, Jay, what you sort of spend the time talking about? What part of the building are we looking at?
Well, so we're looking at two distinct parts of the building. We're looking at, Longboard creates cladding systems, the exterior of a building with extruded aluminum products. They'll look very, very nice. Especially there's a project in particular that we've featured a bit on the Accelerator website, the Montana Museum of Art and Culture, that Longboard did that project. It's absolutely stunning, very textural. But then more important to Passive House and building science, they've created what's known as the Hitch System, which is what we're going to be focusing on in this conversation, which prevents thermal breaks. And it's specially designed basically using passive principles. And as we'll talk about in this podcast, Aaron received a napkin drawing, and I mean that literally, saying, please make this. And he spent about 2 years engineering it from scratch, and really a pretty phenomenal story, and really, really pretty cool that he was able to do that.
Yeah, awesome. All right, well, let's get into it. It's great to have Longboard supporting the work of the Passive House Accelerator. We really appreciate that as a patron sponsor, but also really appreciated the time and input and sharing the story. So let's get into it.
My name is Jay Fox. I am a co-host with the Passive House podcast. I'm here with Aaron Frazier of Longboard. We're going to discuss mostly the newer product, the Hitch System, but also we're just going to get a chance to know Aaron a little bit more and some more about the company as well. So Aaron, thank you so much for being here.
Thank you for having me. Yeah,
absolutely. And I guess just the first question, just about your background. What's kind of your work experience and your educational background?
Yeah, for sure. I came to not only Longboard, but architecture, I guess through a bit of a roundabout way. Came out of high school, a little uncertain of myself, as you do, and my journey led me into the trades. And so I got into the automotive glass trade, and then the residential and commercial glass trades as my kind of leeway out of high school. And my career progression and my hobby progression are kind of how I ended up here. And so I moved through those trades, and kind of downstream moved into the automotive trades in terms of management and running automotive and industrial type shops. But alongside of that, my history has been since 16, 17 years old, building cars, building hot rods, building trucks, and these sorts of things. And so through that journey, part of what I tried to encourage myself or put myself in a position to do was learn how to design and create and build my own parts. I certainly didn't have a ton of money as a young man. And so I learned how to use the tools to do design. I learned, deeply through a decade plus of experience how to compose things and design things and really understand the engineering behind componentry and systems and that sort of thing. And so through that journey, I designed automotive components for the hot rod industry and truck industry. I got into the wheel industry, designing wheels, and I put wheels on everything from Nissan Altimas to I've done a set of wheels on a Bugatti. So like my breadth is pretty wide there in terms of that. And I've designed a bunch of parts for, some exotic cars and that sort of thing as well. And so that's kind of my journey through design. And, in doing that and teaching myself, I learned a real appreciation for, the principles of good design and simplicity and, understandability and just being intelligent with material consumption and these sorts of things. And so a few years ago, I guess about 5 years ago now, I got a I'd known for some period of time. And he said, hey, like this company's Longboard is looking to put a design team together. They've been designing off the side of the owner and one of the VP's desks up to that point. And so they want to actually put a team together to start creating products and be very intentional about it. And so I came in, had an interview, with the owners and the senior leadership team. And then I turned the job down.
I said, really?
No. Yeah, I did. Yeah. So right at the beginning of COVID, just kind of the whole thing breaking free. And I was in an industry where I was secure, where I understood what I was doing. I was in, the heavy industrial service management industry for forklifts specifically. And I was uncomfortable. I said no. And it was probably a month later, chatting with my wife, maybe more clarity there. My wife was deeply encouraging me to reconsider my decisions. I said, maybe I've made a mistake. Maybe I stepped past something that was probably a fantastic opportunity. And so I came back, I won't say the word crawling, but certainly tail between legs and said, hey, guys, I passed on the opportunity. I think I've made a mistake. I would really love the chance to reopen that discussion if you're open to it, and the VP and the owner here at Longboard made me work for it. Maybe, go through a project, a simulated design project to show kind of some of my approach, some of my design language, and kind of how my thought process worked. And I went up against some other candidates at the time, and very, very thankfully, my approach made sense, and I was selected for the role. And so, 5 years later, going on 4.5, 5 years later at this point, the Cinderella story has come, full circle. But yeah, I almost walked away from this opportunity.
Well, that would have been unfortunate. I like the enhanced motivation of your wife.
Yeah, she's very encouraging.
Nice. And I mean, were you coming in with, I know you have, as you said, more of a design background, but I mean, were you working with aluminum a lot? I figured you would with automotive. Or
yeah, so the predominant scope of what I did, through the wheels, through automotive components, and even into, I designed some stuff for boats and yachts and just random strange things. 95% of it was aluminum. So I had a good understanding of not only the material, but some of the fabrication and production techniques used. Yeah.
Great. And I mean, that goes right into, some of the products of Longboard. Let's get into, what you do manufacture and how you go about manufacturing it.
Sure. Yeah. No, I mean, certainly our company, the core of what we do is extruded aluminum. And so we're not only an extruder, but that is how we produce some of our products. And so our mainstay products would be, some of the battens you see behind me, the Lincoln Lock. It'll be our tongue and groove products, or, our plank products that would mimic that wood siding, or the siding or cladding products, predominantly cladding. So most of our product is done through our mainstay production techniques of extrusion, and we own the entire product, production process. So we're fully vertically integrated. We do the extrusion, we do the powder coating, we do all of the wood graining here in house, which it allows us a nice depth of control in terms of quality and the product we produce. And then we step outside of that a little bit. And so we do, the Hitch System is a great example of where we step beyond that space of extrusion, and we get into some fabricated components that we do with, some very high-end, laser machinery and CNC machinery. We're also stepping into a space of getting into some panelized systems, a medium scale panelized system. And we're looking also downstream at some large scale panelized systems. And so we're getting into sheet fabrication and that sort of thing as well. But the mainstay of our business is still going to be in that extruded space.
So these products, specifically the Hitch system, maybe some of these cladding systems that you've described, can these be used in high performance and or passive house construction?
Yeah, sure. So, if we look at, we'll start with maybe the cladding products for sure. If we look at the cladding product in terms of passive house, so it's an aluminum extruded product. It's, obviously quite durable. It's a higher or thicker gauge. So structurally, it's very capable. It's very light, which is a benefit. And we've looked at, also the product in terms of material consumption. So not that that's specifically a passive house piece, but that we're considerate of the environment just beyond the thermal energy and the energy transfer. So yes, it absolutely can be used in those environments, and we encourage it, right? We want to see our product on the wall, but also it's a durable product. It's going to be long lasting. It's going to reduce the embodied carbon through the life cycle of the building, and so that's something that we would definitely say is a product that we can use, in the built environment. If we step into the Hitch space, which is going to be our more focused product in terms of passive house, absolutely, right? So our product is an advanced component certified system, in the moderate climate space. And so it's designed for a pretty broad range of applications. And we can go anywhere up to 15 PSF in terms of cladding load, which is not insignificant. And we can do that up to 16 inches off the wall. And so we've built our product with, that future use case in mind, in terms of we want to be able to get those thicker, layers of insulation external. It's more efficient. Certainly it's, where the industry is pushing, and in terms of anywhere in the industry where they're experiencing significant climate shift, right? And so our system is quite, versatile in terms of, the way it can be deployed, but also it's designed to carry, anything from an aluminum, which is, £1.50 a square foot, up to even some of those, stone veneer type products at that deeper, instance. So it's quite versatile.
All right. So, speaking of the Hitch system, I'm curious I would like to dive a little deeper into that and better understand exactly what it does. I guess, can you describe what it is and how it helps improve building performance?
For sure. So what the Hitch system is, it's a cladding attachment system, right? And so the idea of a cladding attachment system is it allows that external barrier. And so when I say external barrier, it allows that external insulation. And so what we've understood, and certainly what passive house has allowed us to understand, but in the broader spectrum, any insulation that's inboard of that outside, structure, inside of that substrate. So if it's between stud or whatever that might be, there's a significant inefficiency, right? The insulation itself performs quite well, but those studs are significant thermal bridges, and you get a lot of thermal energy transfer in and out of the structure depending on the time of year. And so a cladding attachment system allows you to push more of that thermal control to the exterior of the envelope, right? And so the cladding attachment system, and specifically Hitch in this case, it allows us to basically only have penetration points, so small areas where we're connected back to substructure, and it pushes a new structure forward that allows us to attach our cladding to. And so by doing that, we're obviously having a more continuous installation, We're having less points of penetration back to the structure, which means less thermal transfer back into the structure. And effectively, it also allows us to create unique instances across the facade. We have some great modularity in our system that allows us to do some very unique things, but the mainstay is that we are controlling those thermal penetrations and reducing the amount of thermal energy transfer back into that building envelope.
Excellent. Well, that's crucial part of passive house design and construction.
Sure.
So I think may have heard this story before, but I'm a little curious, how it was actually engineered and the evolution of this system, how you designed it.
No, for sure. if we talk about kind of the lineage or the history of the Hitch system, we actually have to step back, I think, a little bit before that. So we had a previous cladding attachment system, at Longboard here, and we called it the Simple Clip. And, we had it in market, and it was out there, and it was a decent system, right? But there was some, and I don't want to use the word shortcomings, but there were some areas of growth in terms of technology and understanding and capacity and capability that we understood. And so laughably, the Hitch system was brought to me by the owner in terms of, hey, we need to develop a cladding attachment system that's a little more forward thinking. And when I say it was drawn on a napkin, it was drawn on a napkin. So conceptually, there was, a napkin with a hand sketch that was quite comprehensive for what it was drawn on, but certainly left some room for interpretation. And so we took that initial idea, that initial concept, we put a lot of thought into it. We talked about the material utilization, we talked about size, we talked about scale, we talked about functionality in terms of capacity, and even and this is not maybe early phase, but downstream, how do we create more modularity and ease of use in the system? And so that initial Hitch clip if we go way, way, way back, would have been an aluminum base, an aluminum tube, and, not dissimilar in aesthetic to what we're doing now, but a little bit larger. It was a 2-inch variant. And we quickly realized a number of things. One is aluminum is not the strongest material as you get into those deeper tube spaces. Certainly there's other materials that are going to create higher structural capacity. The other one is, as we made the aluminum thicker to create some of that structural capacity, quickly you realize the amount of thermal bridging and thermal energy transfer capacity that material has. And so, that pushed us into a space of looking at some different materials. And the one we selected and the one we opted for is stainless steel, right? So we opted for a 304 tube that we get produced, for us specifically in terms of the sizing. But our mainstay, the main, interference, or the main isolator, pardon me, is going to be that stainless steel tube. And so we have it in a number of configurations. We have 3 configurations of the hitch clip, and then, 40 odd sizes of it, depending what you're doing. But all of them use at least, the stainless steel tube as the isolator in the system. And then some of them have different bases, and some of them have different, componentry within them. So this one, for instance, this will be our smallest. We call it the SD variant. This goes from 1 to 2.5 inches of insulation. And this is just a tube we put on our, we have a tube laser here that will profile out and cut. We'll bend it down, add a base plate. And this, allows that structural capacity, but very shallow depths. And then we step into some larger ones. We get into, this will be an HD variant, a small version of the HD variant that uses, a base and a tube. And that tube, because it's, very thin wall, 1/16 of an inch, doesn't have a lot of material, which means it doesn't have a lot of thermal capacity to transfer energy back into that structure. And then we also have these thermal isolators in a number of locations that not only isolate directly metal to air contact, but also at the base, you'll see it isolates that fastener away from the base as well. So you're just not getting those areas of thermal interference and thermal transfer.
Right. And when you're actually on the job site and installing it, do you get a little wiggle room? Is there a little give to the
so that's the thing,
adjustable?
Right? We understand there was a lot of consideration put into not only the design and the functionality, but also the ease of use, right? The design for installation was a thing that we considered deeply, not only internally, which we appreciate can be in a vacuum, right? We have ideas on how things go on the job site, certainly, but we took a lot of outside input as to things, that were actually experienced on the job site. So we've done a number of things with componentry. And so for our SD system, it's not an adjustable component system, right? It's a fixed tube size. But we've developed what we would call our thermal isolating shim, which is an 1/8 of an inch shim, and it's designed to go with the system as a base thermal isolator. But it's also designed with these slots. So if you're installing it, you can actually put 1 to up to 1/4 inch of those in behind it as you're installing it. So you can control plane, and certainly walls are not straight, walls are not square, walls are not, plumb all over. There's going to be some variance. So this allows you to set a baseline and then adjust that out. And then we get into the HD variant, and the HD Plus functions very much the same. It comes pre-installed with that screw on the bottom in that slot. And that slot will allow a 1/2 inch out or a 1/2 inch in of variance on the wall. And then you come to the top side once you've tightened that bottom screw, and then you do a self driller through the top, which is supplied with the hitch. And that self driller effectively pins it in location, and then you get that 2-point fixture. And you'll even see this is the plane that top screw on, and this is the plane that the bottom screw is on. We've even offset the planes of fixture, so you don't get rotation laterally. You get a nice tight and controlled amount of lateral, stability as well. So there's a lot of consideration put into the design and the use of the system.
Wow. And I guess still speaking of the job site, when you're actually installing it, into some type of insulation, let's say you're using, I don't know, fiberglass or mineral wool or something. I mean, how do you actually attach it onto your wall? Like, is there a tool that Longboard has devised that's kind of makes it a little easier?
So we have a couple of things. So when you get it, the cap will be on there. You're going to pull that cap off, right? And so the intent is that this cap gets removed. We actually have a tube or a tool that slides over the end of the tube, and that tool is about 6 inches long. We call it our piercing tool. And so typically with insulation, you would put the clips on the wall, do some measurements, kind of, ascertain where that insulation is, get a knife and tear your insulation apart, right? And you cut it up and kind of fit it around it. And one of the things we recognized in that process is there's a lot of room for gaps. There's a lot of room for air movement. There's a lot of room for, lack of kind of a tight fit. Also, our tube is hollow, and so I'll speak about that in a second. But we've developed a tool. It's a piercing tool. It's, a sharp spire that effectively goes on the end of this, just a sheet metal tool that's reusable. And after you put the clips on the wall and adjust all of your plane, get that all set, You put those on, and every time you put a piece of insulation up, you put it on the front, you push it through, and it pierces a tight square right around this. So this, the fit up is snug to the tube, and that allows there to be no room for air movement, or no room for that thermal air movement between the outside and the inside of the insulation. Also, it allows us to core out that insulation, and sometimes you want to control some of the air movement inside of the tube. Steeper tubes, you'd want to put a few inches at the end of it as well, so that you don't get that air coming out to a colder space. And so you can take that core and put it back inside the tube. And so we've been considerate of a number of these things, and it simplifies the installation too. You're not sitting there measuring and cutting. You put it up on the wall, you get it lined up, and you get two guys to push it through, or one guy to push it through, depending on the size. And it effectively makes it a much more efficient installation in terms of time, which is, we recognize a lot of people look at these types of components, cladding components, as a cost of component, right? And so cost of component is a part of the component or part of the system, but we have to look at the cost on the wall. We have to look at that labor component as well. And if we can help reduce that part of the installation, I think we're trying to, we've accomplished. We're trying to provide more value to that end user and look at it more holistically and not just on a component basis, right? So.
No, I mean, if you're going to be able to do it quicker and easier, it's going to be more, you're going to be able to do more in the hour. And that's just that.
For sure. And we've even even beyond, and I certainly don't mean to cut you off, I apologize, but even beyond, just the clip itself, even some of the things we've devised with the girts. So we've got standard girts, which would be a typical hat track shape, like whatever, hat track shape you would see on the market. We've designed it with these slots, and these slots will always line up with one of the holes on our clip. There's an offset there, but it'll always line up with one of the holes, which is something that we wanted to make sure at ease of use. Even the holes on the sides of that black hat, we've isolated where the holes are. So there's no drilling, there's no pre-drilling holes. You just run the screw in. That's our standard girt. We also recognize there's edge conditions and corner conditions. So we've done a girt that only has one leg on it. So it's still quite stiff, but it allows you to get closer to that edge condition. We've also developed a corner girt that allows you, it's 6 feet long, to bend around a corner, but this stays as one piece. And so we've been really considerate of how to tie structure together, create that stability, especially, if you get into some of these stone veneers and more critical types of claddings that have a higher deflection limitation, up into the L over 360, our system does that. It'll play in that space, where a lot of these systems, like Z-girt is a great example of a system that, deflection limitations, they're quite limited, right? So that's one thing that we got a lot of feedback on, and we were quite critical on in the design phase.
Nice. And I guess going into different cladding systems, when you, let's say, you have an aluminum cladding system on your building, it's been 20 years, you want to change it up. If you were to try, if you decide to take it off and replace it with something else, I mean, can the Hitch system remain, or do you need to replace that as well when you?
Yeah, no, I mean, the nice thing about the Hitch is that, it's incredibly durable in terms of not only the initial installation, but if you want to, revitalize the facade, if you want to have a new aesthetic, if you're, different tenants moving in, whatever that might be, our system is very modular in terms of how that might function. And so a couple of things that it does well is, we've created quite a broad surface area where a lot of girts are quite narrow. We've created a very broad face, which allows, downstream, if you do that, you've got more room to attach something to. But even if you decide not to, you don't have to remove the whole system. You can just remove the girts, replace the girts, and, start fresh again. And so it does allow that versatility and modularity in a number of different ways. And this, this system is not exposed really to anything external. It's Galvalume, it's stainless steel, it's, nylon that we've got even UV inhibitors in, glass-filled nylon. So it's very, very durable. It will be there for the life of the building, 2 and 3 facades later if you want it to be.
And I'm going back to the Hitch system. I just actually had a thought, but what's, beyond the stainless steel, what are some of the other materials that are actually used in the construction of the?
Sure. Yeah, no, we've done, so we've got a polyamide or a PA thermal isolators. And so these are glass fill, just in terms of adding a bit of structure to them. So we've all of our thermal isolators, including this little base that I showed you earlier. All of the black effectively is a PA6 with a glass fill that is designed to create that thermal isolation, but create, significant structure in place. It also is designed so that if any of that ever were to be in a, God forbid, a thermal event, that which happens, it's unfortunate, but it could happen. if anything were to damage those plastics, the stuff stays on the wall, right? We've created mechanical fixturing across the whole system. Even though it's isolated, the mechanical fixturing is there. We also run an aluminum base on our HD and HD Plus variants. And so there's a base that goes inside this tube that's made out of aluminum, which, extruded aluminum. It's a higher grade of aluminum than a typical architectural, but we use that because we can really deeply control the structure and the shape through like topology optimization in terms of how we deploy out, the areas of strength. And it's something we can fabricate in-house. And it's just, very, very usable. It's light. So there's a lot of value of using it there, but it's fully isolated. So we don't ever put aluminum in a space where it's going to grab a lot of that thermal energy. And we don't ever touch the aluminum back to substrate or anything that would create, that transfer. And even then, even if you look at our isolators and our thermal breaks, we did a lot of modeling. When I say a lot, like months and months and months of modeling, and then back with our external engineering partners, and then back to us for more modeling, where we have the mass distribution, where we've pocketed it out, even in terms of, I don't know if you can see it, maybe you can, maybe you can't. We've even done slotting and removed thermal mass, from the bases to remove that thermal transfer, right? Because contact transfer is going to be one of the most efficient methods of transferring energy. So if we can remove that contact, we're removing one of those opportunities, and we're creating a bit of an insulation space with air or, removed contact. So we've been considerate of as many kind of features as we can throughout the process of design.
Excellent. And what are some of I guess you could give me maybe a few examples or your favorite example, but just some buildings that have used the Hitch system or Longboard cladding that really, I don't know, interest you from a design perspective.
Yeah, so it's a really interesting one, right? Because we've got the Montana Museum at Montana University is one of the most unique, I think, Hitch installations. It's got a curved wall. It's got some very unique castellated kind of aesthetics, and it uses not only the Hitch, but it uses our cladding as well. That's one of my favorite, kind of pieces. We've done some really unique houses. We did a house in a gated community in Florida that's exceptional on every level. And it's something that was quite large and quite significant in not only in the product, but the way they deployed the product. If I were to look at probably one of my favorite projects, it was actually a custom project we did where we designed an art installation and helped deploy that with another installer fabricator here locally in a building called Alberni Tower. And it was an art installation designed by Ken Gokuma. Absolutely gorgeous. And we did a few custom extrusions and some custom, wood grain colors and stuff for that as well. So our project breadth is pretty unique. We're involved in some cool things, but those would be kind of top three of what I really am passionate about.
Thanks. And I guess that brings up just one other point. Just you do interior products as well, right? It's not just exterior cladding. Longboard does manufacture some
for sure
interior.
Yeah. So I would say that, our products, the primary focus of the product initially was soffits, and then we got into that cladding space as well. And so that is the mainstay of what we're doing. We've got some products that are very specifically focused for interior space for a number of different reasons. And so some of them you'll see behind me. This Lincoln Lock is an interior exterior space kind of piece. In this type of deployment, it's used for sound abatement and sound control. It's backed with an acoustic insulation to try to control some of that reverberation and sound. We've got interior ceiling components that we've got optional sound abatement and perforation options with as well. We've got interior hung ceilings to go around mechanicals, and we're deeply looking at creating some different, ceiling and wall products and systems that will come out in the next few years that'll be pretty cool in that space. So the idea though is we can, have continuity in space. We can bring the outside aesthetic in, and it's very continuous, and the quality remains the same. So.
Very cool. Well, I guess, is there anything else you'd like to add about, upcoming project that you're super interested in, or an upcoming, let's say a product that's coming out a little sooner than what you just described?
Yeah, I would say that, we're deep in the midst of developing an intermediary panel system. And so that is something that we've been working on here for about a year, and we're about, probably 6 months out of really getting it to market. We've shown it in a few places, and some people have given us some feedback, but it's a system that hybridizes, some of these large scale ACMs with our tongue and groove type system, which makes it easy to deploy. My excitement there comes from the fact that it's going to be sold and sent out as a modular system. So unless, you're cutting at the very edges, it's going to be modular and go up like Lego, where no one in the market is doing that yet. I'm really, really excited for that. I think that's probably my biggest one. And then we're looking into some panelized stuff beyond that in terms of perforations. And there's a space there where I think there's some artistic influence and some things that allow us to have a little bit of creative space, which is really, really fun. So there's some some very interesting stuff coming down the pipe. And even in terms of, optimizations of how we're doing some of these things, I love the process not only of creating, but how do we do it better? And we look at that often, and it's, I think, a very rewarding part of the process. So,
well,
yeah,
beautiful. Well, Aaron, thank you so much for taking the time to talk with me. Enlightening as always.
Thank you for having me, man. No, this is really fantastic. I love, that this space is growing and that, people are actually paying attention to being mindful of the energy we're consuming and what we're doing with the environment. So it's pretty interesting stuff.
And I think it's another important factor is just the durability of, better built buildings. They tend to withstand climate disasters, which some of us are getting to experience firsthand.
I mean, we have hurricane certifications on our product, so certainly we're capable of doing what you need down there.
I wish there were more buildings that had that type of system on it.
For sure.
All right, Aaron, once again, thank you so much.
Appreciate it, Jay. Thank you.
And that was Aaron Frazier of Longboards. And check out Jay's article, which is published now. You can find that over on the Passive House Accelerator website of that beautiful museum building in Montana. It gives you a bit of a taste. And there's also a lot more information, including some images and technical data of the Hitch system that Aaron was describing. I don't know about you, Jay, but I think you saw it during your interview, but I was trying to picture in my mind exactly what it looked like. And I kind of got it when I saw the pictures there. Yeah. So yeah. I think this is a really exciting space to see what people are coming up with for solutions to attach the outer skin of a building, the cladding, to the structure. Something's got to hold that cladding on, but ideally not impacting too much of the thermal layer. And that's the challenge that they're trying to address, right?
Yeah, absolutely. And I think another important note that he made and that we go over in the article, and if you go to the Longboard website, you can more clearly see this, but there's a tool that is designed to basically act like an apple corer, but a corer through insulation so that you puncture it and then it, you don't have this extra space where air can get in and cause problems. That's really tight around the Hitch system. So I think that's a really cool thing as well that kind of helps the installer on site, make it a little easier on them so they're not, digging it out with a knife or some other tool that doesn't totally work.
Yeah, and I was glad you asked about that, and I think it shows Aaron's experience as a designer and then also some work with his own tools and doing his own hands-on work. Obviously has an appreciation for the fact that you can draw straight lines on a computer, but in the real world you need tolerances and things are not always perfect and don't always line up. And they've obviously spent a lot of time thinking about that and the variation that you need to allow for in the real world to make a system like this work with multiple different combinations of structure and different types of cladding and all the other bits in between. It seems like a relatively easy thing. It's just a clip that holds the stuff through some soft, fluffy stuff. But I can imagine, in reality, it's a lot more complicated than that.
No, absolutely. And I think that there's a little bit of give that, even the Hitch system has for, because, well, the wall is supposed to be a perfect 90-degree, but, anybody who's been on a construction site has certainly come across many walls that aren't totally plumb. And, he's not living in the dream world. This is a tool manufactured and a Hitch system is manufactured for, actually building. And, it's results speak for themselves. Again, I really think that Montana Museum of Arts and Culture is absolutely gorgeous and just a really cool skin, as you called it, that kind of sits on top of the structure.
You mentioned right early on in the interview about durability, and I suspect that some people might be wary of some of the material choices like steel and aluminium because they can involve a lot of upfront carbon. But I thought Aaron's point was quite interesting in the durability of that system actually makes it potentially a lower carbon option if it's something that is going to look after the building for a long time, and then also potentially be reusable or recyclable at the end of life. Have you covered off that much in your article?
It comes up a little bit. It's not really a focus. The focus is more on the Hitch system rather than the cladding system. But I do think that is what's interesting is that the Hitch is designed to remain in place. So you pop the aluminum off, you can recycle it, change the entire appearance of the building, and then the same system that you attach to the thermal brakes and everything remains there, and then you just pop the new. Sure, it's a bit more complicated than that. You put the new shell on, and you have for a building that wants a new look, that wants a major change of appearance. You can do that and just recycle the previously used materials. So I think that's very cool.
Yeah. But I guess just in general, I think there's an ongoing conversation. I think it's really good that people are starting to think about not necessarily labeling a material or a product as good or bad, but how it gets used and how long it stays in place for. And that's literally the whole point of a life cycle analysis, is that you're looking at the whole life of the system. Anything that offers more durability to the whole building has a significant benefit, which has to be part of that decision-making process. So, I just encourage people not to rule out things like metal or steel, even concrete. They all have their place if they're designed well and put in the right place.
Yeah, and there's several articles in the magazine, which was just released this week, where that conversation kind of takes place. There's a Diane Stewart's article, but also even Northport, I forget the name of it, Up North Resiliency in Michigan, which talks about a single family house in Michigan. They decided to use concrete because of the durability factor. Where, I think some people look kind of askance at the decision, but they said, look, this is going to be dealing with very harsh winters. They have a lot of lake effect snow, and that's why they decided to go with that material. So durability is becoming definitely, just in my interviews that I do with different architects and engineers and builders, durability is becoming a major issue precisely for the reasons that you said. Yeah.
Great. All right. Well, thank you to Aaron. Thank you to the whole team at Longboard. Go and check out today's article on the Passive House Accelerator website, and you've got plenty of links in that article directly to the Hitch cladding attachment system on the Longboard website as well, so you can have a bit more of a look at what we're talking about. And there's a couple of videos there and some projects that they've featuring as well. Thanks for that, Jay. Really appreciate it.
All right. Thank you, Matthew. Have a great one.